Hi, everyone, and thank you for joining on a Wednesday evening, 7 p.m. We're going to give it 1 or 2 more minutes to give people time to join in. So be patient, and we're going to explain you what's going on tonight, what will be the topic, and everything. 1, 2 minutes to wait. Hello, good evening. Just to let you know, we're going to wait 1 minute, 1 more minute before starting to leave time for people to join in. Thank you for your patience. All right. Thank you very much, everyone, for joining. Wednesday evening, 7 p.m. It's always difficult after work, so we'll try to make it as interesting as possible for you. Just a bit of housekeeping. This mentorship is sponsored by Meta. They help us graciously in organizing all that. There's no counterpart. Is just to help spread the word around AI. Tonight, we will have 2 presenters, the same thing as last 2 weeks ago, and the same thing as two weeks later. German is going to present us about serving large-scale models, and Yusup will also share this time about engineering your own job, entrepreneurial thinking for the AI generation. Each presenter will have 20 minutes. We'll leave 5 minutes for Q&A after each sessions. We'll be a bit strict on the time, sorry about that, but we don't want to take too much of your time on an evening. So without further ado, I'll leave it to German to share his screen and to start his presentation. Thank you.
Thank you, Vincent. Let me share my screen. Super. So today I'm going to talk about serving large-scale AI models from a hardware company perspective point of view. A little bit about myself. So I've been working in research for quite some time already, I think 8 to 9 years. I did my PhD in Italy at Politecnico di Torino. After that, I held like multiple positions in Huawei Cloud, working mainly on data center optimization and networking. And finally, I landed here in Singapore, where currently I'm a staff researcher at AMD, working on AI optimization. So what is AI? We have many different beliefs of what's going on in the field of AI. Some people believe that at the current scale, we're going to get artificial general intelligence in a matter of years. It's just a matter of scaling the models, making the models bigger, feeding more data, putting in more compute, and we're going to get there eventually. Some other people are a little bit more skeptical, and they say that what we can get with the current models is emulation or a primitive version of AGI, and we will never be able to get to the actual AGI without a more breakthrough in the AI field. And then on the opposite side of the spectrum, there are people who say that ChatGPT is bullshit. And in this case, bullshit is not a curse word if you are a sociologist. And I highly invite you to read this paper because it's really eye-opening in terms of how ChatGPT works and how it has been trained. But no matter where you are on this kind of spectrum, you cannot deny that there is a heavy investment in this field. So people, companies, corporations, governments, everybody is pouring high amount of money in this domain. And we can see this from the evolution of AI. We have the first simple perceptrons more than 50 years ago, and then we had basically nothing up until 2012. Why this happened? Well, because the data was not there, the compute was not there. And then finally, in 2012, we got AlexNet, which was revolutionary, at least in terms of computer vision. People started to jump on this trend, and in a matter of 6 years, we got transformers, self-attention, and all of the basic building blocks of what lately enabled ChatGPT. And since then, since the day when we woke up, the ChatGPT has been a roller coaster of innovation. We got MOEs, agentic AI, reasoning models, multimodal models, and you name it. Now I'm really afraid of blinking at this thing because every day you get something new. But what is the point of doing all of this? Well, the main point is to try to improve the accuracy of the models. So here we have accuracy on the Y and the time on the X. And what we want to do for any given model is to reach this inflection point at which the model starts to behave better than humans. So it's starting to outperform expert humans. And this is the point where we actually get scientific and technological breakthrough in terms of physics, mathematics, genomics, whatever, you name it. This is the point where AI starts to improve every aspect of our life. But the problem is that nobody actually knows how to get there. This is pretty much an empirical science. So nobody knows whether better reasoning models are going to bring us there, whether MOEs are going to bring us there. It's hard to answer. What people know for sure is that as you keep increasing the size of the model, so in this case, you have the number of model parameters on the Y and the years on the X, and every dot is a different model. What you can see is that as you keep increasing the number of parameters in the model, the accuracy keeps increasing. And in a matter of 50 years, we got something like 10 order of magnitude increase in the number of parameters within a single model, which is astonishing. Now the problem becomes, again, compute. So we have a lot of data, we have internet, we have books, we have whatever. So we have data to train our models. But the problem now becomes how to train it fast and efficiently. So in 2016, at AMD, we had this one of the first AI accelerators, the MI25, which had a modest 5.7 teraflop of compute in FP16 precision, 16 gigs of high bandwidth memory at quarter of terabyte per second, and the power consumption. Now I laugh at this because of what about to come, but the power consumption was in the order of 300 watts. At the same time, the networking was quite modest. So the networking was 100 gigs per second. Now, since the increase of the model sizes, what we get from AMD now is this kind of beast. We have 500 times more compute power in FP6. We have more than 2,000 times more memory, so we can actually store all of those parameters, all of these model parameters in the memory. We have a ridiculous 180 kilowatt of power requirement for this beast, and we have more than 30 terabytes per second of network speed. And I'm going to talk more about why we need such a big memory requirement, such a big network requirement. But the point is that this is not a single GPU. This is multiple GPUs or accelerators, however you want to call them, in a single big rack. And how do you serve these new big models in such a distributed setting? So if we look at this cartoonish picture of model execution within a single GPU, modern models have multiple layers within them. You have more than 60 layers for DeepSeek and more or less similar order of magnitude for Llama models or GPT models. Inside every layer, what it does is just to perform a simple matrix multiplication. I mean, it's not that simple, but it's a general abstraction that shows you what's happening there. And what you do is to feed your query into the first layer. In this case, what is the best tech community in Singapore? This query gets processed at every single layer, one by one, and then finally it reaches the output where the model spits out some tokens, and these tokens get transformed into the actual words that humans can understand. In this case, the answer is, I think it's pretty much obvious that the answer to this question is Better.SG. Now, the question is, let's assume we have ChatGPT. It must serve millions of requests per second. We cannot do this on a single GPU. So what can we do is a naive approach in which we just replicate the model across two different GPUs. So in this case, we're going to have another query, another question coming in. What is the best community project in Better.SG? And again, the answer is obvious. It's cat safe in this case. This is fine. This is good. It works pretty much well, but it only works in the case in which you can actually fit the entire model within a single GPU. If this layer starts to become too big, well, then you have a problem because you don't have enough memory to fit the model in the GPU. So what you can do, simple, just split the model across two different GPUs. So in this case, you put the first two layers of the model in the first GPU, and then the second two layers of the model in the second GPU. And it's fine. I mean, if it's not enough, you can split even further. You can put one layer in a single GPU, another layer in the other GPU, and keep continuing doing like this. Now, the question is, these matrix multiplications can take quite some time. So this A times B, maybe it takes 1 second. It's not a real number, but let's assume it takes 1 second. So the total time to answer your question in this case is going to be at least 4 seconds. The question now is, can we do it faster? And the answer is yes. So what about, instead of splitting individual layers across GPU, we also split single layers across multiple GPUs. So in this case, you just cut these layers and put one half of the layer in GPU 0 and the other half layer in GPU 1. And if you remember from high school, this big matrix multiplication, A times B, can be decomposed into smaller matrix multiplications. In this case, it's going to be C times D and E times F. And what you do them in parallel. And in the end, once that you finish doing them in parallel, you just aggregate them. So in this case, GPU 1 is going to send the result of E times F to GPU 0. GPU 0 internally will compute C times D. They will aggregate it according to some function. And in the end, you're going to get a result here, which is the original A times B. And you can repeat this across all of the layers. The result now is that you're doing these layers in parallel. So you're doing it at double the speed. So in theory, if before executing this model would take you 4 seconds, now it should take you 2 seconds. I say should because in reality, it's not the case. As you can see from the red arrows, there is a reason why they are red. Because I told you that you have some communication between these GPUs. So you need to send these activations between different GPUs. And sending these activations takes time. You have to access the network. You need to package your data. You have some delays related to propagation. You have bandwidth limitation, and you name it. You have so many different problems there. And the point is that this layer here, it cannot advance in your processing of the queries up until to the point in which you receive both C times D and E times F, which means that if the network is too slow, you end up in a situation like this, in which the networking is doing most of the work and the compute is staying idle. And every single time the compute is staying idle, you're wasting power, resources, and overall money if you are serving, if you are, for example, OpenAI and you are serving ChatGPT. So how can we solve this problem? This is the representation of what's going on over time. So you have compute on this line, you have communication on this line. You compute C times D. After finishing computing it, you can send it out to the other GPU. So in this case, you're going to be sending C times D. And at the same time, you're going to be receiving E times F. While we are sending and receiving, as I said before, we are wasting compute power and compute capacity. And we usually refer to this as bubbles, compute bubbles. And we don't want this because this is wasted time that we can sell to the customer or we can use it for something else. So how can we solve this problem? Let's have a look into some potential solutions. So one simple solution is, I told you, we can split this matrix multiplication into smaller matrices multiplication. And this is what we do here. We do chunking of the original matrix multiplication into smaller chunks. In this case, we have 4 of these chunks. The effect of doing these chunks is that once that you finish computing one of the chunks, you can start sending it out. So you can actually start to overlap your compute and your communication. The final effect of this is that the idle compute time is reduced by quite a lot. Now you may say, okay, let's chunk it as much as we can. It's not that easy because every single time you chunk your matrix multiplication, you are actually reducing a little bit of compute efficiency. So your compute becomes a little bit slower, if you want to say it that way. So there is like a sweet spot between the chunk size and the amount of idle compute that you can get. Okay, but now the question is, can we get it a little bit better? So maybe, are there any other techniques that can improve and reduce this idle compute? A lot. There are a lot of different techniques. One of them is quantization. So you may want to perform your compute in FP16 precision, but then you say, okay, I'm going to quantize my activations and send them in FP8, which means that you're actually sending half of the data because you need less bits for every activation that you are sending through the network, which again means that the communication is going to be faster. The problem with this is that you need the model to be informed about this because you're going to have activations with less precision, which ultimately can affect the accuracy of your model. If this is too complicated for you, what you can do is to perform compression. The same way that you compress a file on your desktop, you can do this. You can apply the same approach for these activations. You look at the bits, you find patterns, you compress them. In the end, the result is going to have less bits to transmit over the network. Again, if you cannot do this or you're just out of ideas, just throw more bandwidth into your infrastructure, which means adding more links to your GPUs or your servers, or maybe just increasing the link capacity. You go from 100 gigs to 400 or 800 or you name it, whatever is your ability in scaling your networking. But again, the problem there is that you're going to increase the power consumption of your entire setup. And increasing the power consumption means that you need bigger data centers, you need more cooling, you need a more stable energy grid to support your data center. So There are trade-offs in applying these different techniques. What we do at AMD is actually analyzing these trade-offs and trying to come up with optimal or close to optimal configuration for deploying these big AI models. And the answer is that there is no one-fits-all configuration for serving these big AI models, because it depends on the factors such as the model that you're using. If you're using Llama or DeepSeek or Qwen or whatever new model came up this morning, it depends. It depends on the model size. So small models are simpler to serve. Bigger models are more complicated to serve in terms of synchronization, in terms of variable compute times. A lot of different issues with this. You have different modes, whether you are doing training or inference. In training, you need throughput. In inference, you need latency and SLO, which affects how you deploy those models. It depends on your infrastructure. So network transport, whether you have InfiniBand, Ultra Ethernet, or RDMA over converged internet. It depends on your GPU. It just depends on the parallelism that you use. It depends on many different factors that are really cannot be taken into account by a human being. The output of this deployment blueprint is the model performance, which in our case is throughput of the model, cost, and power. And I've been focusing a lot of cost and power in this presentation, and there is a reason for this. This is my last slide, and I just want to leave you with this, just to show you what's going on in AI right now. You have a lot of very smart people at Google, Meta, working on improving the model accuracy and model capability by developing reasoning models, agentic AI, trying to achieve better accuracy and better results from the model, with the ultimate goal of enabling applications that generate revenue, such as robotics, code productivity, neural rendering, whatever comes to your mind. But the problem is that if these models are too expensive to use, if it costs you $1 per API call to ChatGPT 5, 6, 7, whatever it is, you will never be able to generate to create model revenue generating applications. And this is where hardware companies come into play. What is our objectives is to minimize the cost of serving these models, which in the end is the main factor that enables the what we like to call the AI revolution. So I hope it wasn't too boring for you. I have one last slide with shameless self-promotion. So if you're interested in these topics, we're looking for interns. So if you are a master's student or PhD student, get in touch with me through LinkedIn or through emails. Or even if you just want to talk about this topic, please get in touch with me. I'm really happy to discuss about this. And the second most important thing is that we're looking for a hardware engineer for the project that I mentioned before, for a CAD safe. So if you know how to do PCB design, or even better, you are into antenna design, please get in touch with me or with Summer. So yes, thank you very much. I think just in time, 20 minutes. So thank you very much for your attention.
Thank you, German. Yes, you did it. 20 minutes exactly. Congrats. I was a bit afraid about it,
yeah,
but that's
no worries.
No, it's fascinating. I think everyone talks about AI, about generative AI, ChatGPT, application layer, but it's actually quite rare to get into the details of the hardware layer. So super interesting to hear about it. Thank you so much for the sharing. Actually, we don't have any questions in the chat. What I suggest is that we shift to Yusup for his presentation, and we'll take all questions at once at the end of the session. All right, thank you, German. And Yusup, up to you to share your screen and go ahead. 20 minutes.
All right, thank you, Vincent. All right, I hope you guys can see my screen. Let me start over here. So there's a great presentation from German about the hardware side of AI. Now I'm going to the other side of the AI, the human side of the AI. And I think a lot of people, when we jump into the learning AI, the typical job role that we are looking for is becoming AI engineer, right? But what I want to share today is that there are actually a lot of other roles out there where you still can using AI in a different way, right? So, right. Okay, so before I start, my name is Yusup. I have about 23 years in the IT industry, mostly on the software development. So have been building a lot of website, mobile app, AI, you name it, right? And then now I'm doing my own startup where we're actually building our own AI from scratch. Not the Gen AI, but we are more on the machine learning plus a bit of deep learning, and we leverage on the Gen AI for presentation side. So today we are a lot in the understanding character or the personality of the person and recommend what kind of career that is suitable to you. So without further ado, right, today a lot of people has started to pick up AI, right? And even like parents, our older generations have started to learn how to use AI. So the playing field is becoming more competitive. There are a lot more people know how to use AI. And it is not enough for us to just know how to use to become a prompt engineer. The typical challenges that we keep on hearing today is that in terms of the job vacancy, a lot of organizations try to hire the Superman level of the AI engineer. If you read the news from Meta, right, they are spending like hundreds of millions of dollars to hire those top experts in the AI industry. And then we hear there are a lot of releases of the new models. All these company like ChatGPT just released the ChatGPT 5. There are a lot of progress in the Gen AI as well. So the market is keep changing, and how are we expected to keep up to the pace, right? To learn all this technology, and if we look at the market, what is the job requirement in the 3 to 5 years later? It is very difficult to predict nowadays because technology are changing very fast, and of course, a lot of people are worried. But on the other hand, the good news is that this is a level playing field for everyone, right? So it impacts everyone. So I think what I'm trying to propose over here is that instead of worrying that, okay, can I be AI engineer? Can I do AI? Maybe we should look at the other way. What is my profile? What am I good at? And how do I use it to shape my career? Right? Look at inside out, right? What we can do better. And especially now, today, the community is all about AI. So how do you leverage on your trade to make the best out of this AI job? So I just want to cover a little bit like why it is important to understand your strength, right? Just some statistics that we have been looking at a lot of our data, and just a quick sharing that when we look at the top 10 billionaires in the world, we notice that 8 out of 10 of them are very self-directed, means they know what they want and they are very focused in getting what they want. 9 out of the top 10 billionaires are strategists. That means they are problem solver. They look at the big picture, they look at the long term. 9 out of 10. We feel that it's no coincidence that if they are very self-directed or they have high strategic thinking, because when we also look at the typical trait of a software developer, they are very analytical and creative because you need to look at how to code in a very structured way. Plus, if you want to become AI engineer, what we notice is that generally you need to have a very investigative mindset. You need to be able to look at the big picture and how to solve the problem. Now, when we also look at the top AI people in the market, a lot of these people are coming from the science point of view. They are the researcher, they are the scientists, they are the technical person who actually create or build or develop the AI model, right? Now, if we look at a lot of these few people, more from the big corporate like the DeepMind, Deep Learning AI, Andrew, OpenAI co-founder Ilya. If you see the table, most of these people have a very good strategic thinking, analytical thinking, creativity, investigative mindset, and so on. That is the typical trait of AI engineer. Okay, I'll come to why I'm sharing this. Okay, but what we want to show is that the world of AI is not limited to just people who are strategic thinker or investigative or analytical and so on, right? So don't worry, right? Don't worry if you feel that, oh, I don't have this trait. What is going to happen to me, right? Should I change my my job or my career? No, that's not what we are trying to say. It's just that we are saying that the scientist side, there are a lot of people with this trait. But if we look at the business side of things, so there are people like, for example, Sam Altman, which is a very much business person who grew the OpenAI. So his trait is very entrepreneurial, very authoritative, or having a leadership trait, strategic thinker. And if we look at Eric Smith, Mira Murati, all the C-level in this AI company, they are very much entrepreneurial trait, not the investigative, not the science trait. Now, how do you understand your trait then, and how can you fit your trait? How do you understand like what's your SOP to be able to fit or maybe to customize your job to fit into your strength? So actually, I want to touch a little bit on the personality assessment tool. Actually, I'm not advocate of like whichever tool is better than the other tool, but there are all these tools has a different purpose. If you study all these tools, they help you to understand yourself in a different segment. But what I want to use today, and this is quite popular in Singapore actually, because it's also used by the Skills Future and the Workforce Singapore. They recommend to use Holland Code Rysec, which is also used by the Strong Inventory. So I just want to use this as an example, but this is not the only example. I just want to show this how you can understand your profile and understand how you can create or define your own SOP in working in the AI industry. And when I say create, that's where I want you guys to put in a little bit of entrepreneurial thinking, not asking you to be a businessman, but ask you to be like a strategic planner. Think of the long term, right? What is it in it for you? So just one quick cover. I'm not going to go into detail, but there are 6 traits or 6 types that this Rysec is covering. So as you can see from the first initial of all the letter, realistic, basically a doer person. You like to be hands-on. You like to get your hands dirty. And then investigative, these are the thinker. You like to look at the theories, the facts, the data, the numbers. Artistic, these are the creative people, the innovative people. You like to design, you like to express your ideas in a certain way. Social, you like to help other people, you're outgoing, you are easy to connect with other people. Enterprising, these are the typical leader. You're able to persuade or to influence other people on your ideas. And then conventional, these are a very structured person, a very organized, very detail-oriented. Now, it doesn't mean that you can be only one of the type, or it doesn't mean that you will be always one of the type, right? Our preferences can change, but usually it doesn't deviate a lot. And maybe you also have a preference on a few combination of this type. You can be realistic plus investigative, for example. But to do this proper test, actually you need to pay money, about I think $50 for the assessment. But I'll just do a quick, simple test for you to be able to reflect and validate which type you prefer. Right? There's no right or wrong. It's your preference on how to do things. And I'll share with you a little bit on how you can use that strength in the AI industry. So let's take a look at the first one, realistic. You are the doer. You're the hands-on person. You like to build things. You like to get your hands on like tinkering with things, break down like your car, your tools, your equipments, right? So you like to see how things works. And these are usually you're energized by practical challenges where you can get your hands dirty. Now, if you feel that you are this type of person, these are the usual software engineer or data engineer, because these are the people who can get the hand dirty, build the pipeline, build the software, or maybe build the whole data pipeline. Right? These are the typical engineer profile, right? And this is usually the default profile that people think when we talk about AI. Now, if we go to the second type, investigative are thinker. So that means you will use your brain more. You like to solve puzzles, you like to look at maths problem, you like to research, you probably have a big question like what's the meaning of life? And you enjoy that, okay? And if you notice that people saying that, oh, you are too detailed, or you're thinking too much, or you're thinking too deep, you are probably a thinker person. And how you can become a thinker in the AI space? So the thinker person like to analyze things, and these are the typical research and experimentation domain. So you like to look at big data, a lot of data. You like to look at how to find patterns out of the data. And so these are the typical data scientists, right? So if you differentiate between data scientist and data engineer, engineer is the one who built the pipeline, the software. Data scientist is the one who trained the model. Use your maths formula, your statistic to come up with an AI model, right? So a lot of time people also confuse, like, or people ask like, oh, should I be data scientist or should I be data engineer? Right? So if you are a doer, there's a data engineer. If you are a thinker, there's usually a data scientist. Usually, not always, usually. Artistic, you are creator, you like to create things, you like to express your ideas. And a lot of time you don't like to be restricted by rules, right? You enjoy storytelling, you like to design things, or you like to have a unique experience. So what can you do in the AI space? So usually this is the people that maybe can work in the AI creativity, for example, like in terms of the image generation, video generation, text to speech. So this kind of AI that actually produce certain output, right? Not just text, but in terms of like images, videos, sound, and so on. So these are typically a more, if you have the artistic trait, it'll be good for you to become like a product manager, product owner in the AI space. So at least you understand how the technology works. You probably don't need to get your hands dirty to remember all the model or the algorithm out there, but at least you understand the concept. Right? How do you do your clustering? How do you do all your let's say neural network, deep learning, RAG, and so on? At least you understand the concept and how things work, and how do you put the things together. Next, if you look at the social, if you like to help other people, so typically this is more like in the education space where you will get a lot of energy by interacting with other people. So you like to share things with other people, right? And for social people, if you feel that you are someone who probably extrovert as well, you like to mingle with other people. So generally, you can be like the AI evangelist. You are the one who go out there and teach people how to use AI. You are the one who apply the AI in the certain industry or the domain. If you look at like the Gen AI, like ChatGPT, Gemini, Cloud, and all that, those are a very, how should I put it? It's like the engine, right? But where are you going to use this Gen AI? You need to solve a certain problem in a certain industry. And this is where you can actually look at the application of the AI in a very specific industry. It can be a very vertical type of application. Is it like AI for wellness, AI for education, AI to help young children in learning, or AI to AI companion for the elderly, for example. So those are a very application type of AI. And then next type, if you are enterprising, you like to solve problems, you like to take on challenges, you like to lead a big group, you are energized to actually pitch your ideas and rally people to believe in your cause. You like to take risks. Maybe you have this enterprising trait, and how can you use this enterprising trait in the AI space? So these are the profile, like all the C level that I showed you earlier, the Sam Altman, the party, where you actually try to convince people on why AI is important or useful in your life, right? So these are the typical startup founder, C level, or even business development, venture builder, or innovation lead. You don't have to be engineer or data scientist, right? But you can still venture into the AI space as an entrepreneur. The last type, conventional. If you are a very structured person, you love order, you love rules, you like to look at number. If you are not going into AI, you probably become accountant, for example, or auditor. Then you are probably a conventional person. You like rules and order. You like everything following the order. So for this, typically the role is in the data governance or compliance or ethics. Then you can see that, let's say, for example, how LLM gather their data. Is it ethical? Do they compromise copyright or certain infringing a certain company's IP, for example? So there is a need of this role in the space to actually set the rules, how to govern the practices in this industry. So these are the typical, like the AI ethics officer, risk and policy analyst, AI regulator, data protection specialist. So now I've shared a lot of different traits over here. I hope you can get a bit of sense and you can do a bit of reflection. What is your preference? What's your strength? What you like to do? And then try to see if those are the things, how we can operate in that domain, in the AI domain, right? And just a quick, last but not least example, right? Big question, should we all become engineer? Well, engineer today paid quite well. Like, but of course, these are like the top computer scientists out there. Fei now people estimate her net value is about 32 million. Andrew Ng, 80 million. These are the scientist profile. But if you are not scientist, then what's going to happen? What if you are the leadership profile? Mira Murati, 1.4 billion. And Sam Altman, 2 billion. Now, I'm not saying that if you go into entrepreneurship, you will get more money over there. Not necessary. In fact, not many entrepreneurs can talk AI language. More scientists can talk AI language, right? So maybe the pool is bigger to be engineer, right? But the pool is very small as an entrepreneur. But how do you make your way to be like the big fish in the small pond, basically? Right? That is how you can engineer your career. Last one, everyone is saying that, okay, AI can replace us, engineer, or someone who knows AI will replace us. But I see the other angle is that if you don't know how to operate, you are also wasting your time. Right? While people are picking up on AI, maybe you are going in the wrong direction. Don't waste your time over there. Right? Try understand your trade, what you can do best, and leverage on that. Right, with that, that's my last slide. Thanks for the attention and happy to take questions.
Thank you, Yusup. Super interesting. And we have a few questions in the chat, but I want to ask you one first. I got the opportunity, so let me do that. Most of these frameworks are focusing on your strengths, right? Your top 5 strengths, these kind of things. Today, in what you see, what would you say is the most important strengths when it comes to deal with how AI might replace job, might replace ways of thinking? Which strengths should we really try to develop?
I would say the strategic thinking and creativity, because I think the good thing is that AI still cannot do a lot of things. The most popular AI today is like the Gen AI, but it's just a language model. And if you think about it, basically it can talk only, right? There are still a lot of opportunity for us to do anything to do with physical activity. Well, the robot side is catching up. Anything to do with creativity, as in sometimes human can be quite creative in our own environment, right? Not the type of like creative in creating a picture or video, but how do we solve a problem in the real life? That is the context that we have, because we have been, let's say, living in Singapore for 20, 30 years. We understand Singapore very well. And we understand, for example, like if we ask you where to find the best food in Singapore, you probably know on top of your head. But if you ask ChatGPT, that's probably just another search engine to find something. So I feel that creativity in finding your way, finding solution, is still very important. I don't think, in fact, prompting skill itself is part of creativity. How do you structure your prompt question? Right? That is creativity. If you don't know how to do prompt properly, then I suggest to you maybe do all this like a chess, learn how to do chess, all these sports where you can sharpen your creativity or your strategic thinking skills. Yeah, so I think these two traits.
Thank you very much for sharing your view on that. Question for German. Besides power, cost, and throughput, are there any other inputs that should be considered when thinking about trade-offs to different configuration? I'm going to enrich a little bit the question, because at the end we also have a second one asking about should we learn about reasoning model? I think what are the trade-offs in consideration to have when it comes to these models, but also where do you see the future of these models? Is it more agentic? Is it more integrated models with capabilities to access data? Or is it reasoning model? Can you give us a bit of your view on that?
Yeah, I think this is some very, very good questions. So to answer the first question, what should we optimize for? Think about modern applications. So we have self-driving cars, we have robotics, which is coming in a matter of years. So we don't need throughput for that. We need high accuracy, which is appropriate to the model, and low latency. So when you're serving this big model, we're showing you how you can split the layers to answer the questions faster. This is one of the things that you should be optimizing for. But it comes at a cost of more power, because you need more GPUs for this. You need GPUs to process your questions faster. The question about the reasoning models. If you ask Apple, they will tell you that reasoning is not important. If you read their last paper from some months ago, they say that reasoning actually doesn't do anything. It just provides a couple of examples for the model. And then the model just reads those examples and spits out the output. Whether it's important or not, again, nobody knows. It's an empirical science. One thing that we really know is that making the models bigger makes it more accurate. Yeah. So the answer to the last question, I think, what we should look for in the future, I will be keeping my eyes very focused on robotics. I think ChatGPT is not the real threat. The real threat is robotics, because once we like to call it embodied AI, because in the end it's just AI put into some shell that can walk around, and that one will start to, let me say that way, steal the jobs, because then you start to remove all of the low-skilled workers, which are the backbone of our society and are the majority of people who are working right now. And then I'm afraid we're going to start to have troubles. I'm very pessimistic about this, but this is just my opinion. Yeah.
Thanks for sharing. And so another question, I think more for you, Yusup. You talked about strengths, but strengths for individuals. We know that companies which have only one founder are not very successful. Companies who have too many founders are not successful either. The sweet spot is usually 2 to 4 co-founders, right? So the question is really about how do you build this kind of efficient team where people complement each other, where there's a common mindset. What are the traits of personality or mindset that you would look for to assemble such a team?
All right. Great question. In fact, I'll share from my own experience. Okay, I'm not sure if there's a right answer out there. I feel that it's probably more on the preference on the leader on how they want to create the team or the culture that they want to cultivate in the company. So for me, when I interview the candidate, I will also ask them to do the personality assessment. That's not to judge them, but to understand how they like to work. So for example, in my team for the data engineer, I will focus on people who are more analytical and creative, like the example that I saw earlier. I do have, for example, social media specialists. Their job is literally to create content and post to the social media every day. This, I will need someone who are really, really creative, like super high in the creativity, and need someone probably a little bit extrovert, like really go out and engage the audience. So it is important for us to identify for each of the job role, maybe what is the style of the working that you expect from the team. And I'm not saying that for engineer you only hire analytical and creative. There's still good use of if you have a different trait. So for example, for me, although I started as a software engineer, my analytical isn't very strong. So I always look at the big picture. So and because of that, I'm the integration guy. I look at how to connect systems as a developer. Right? Not go deep in one system, but go wide multiple system. So that is how I use my trait and leverage on that to be to use my big picture thinking process to become a software developer. And also there are a different type of, let's say, for example, a very conventional software developer. They are super good in production support, and they just like it. They just like it, which is good because sometimes when the system is down on after office hour or during the weekend, they are always ready to jump in and happy to solve the problem for you because they just want to make sure everything's correct. So I wouldn't say there is a one ideal profile. It is more for you as the founder, identify what are the profile that you want in your team, how you want them to interact with each other, what's the culture that you want to build. Is it a very social culture? Is it a very to the point culture? Or what kind of culture that you're looking for? And then I think one more thing I want to address is that as a solo founder, I don't believe one person can do everything. Not because of capacity. I think everyone is competent enough. We don't have enough time. We don't have enough time to learn many things. It is best to outsource that to your co-founder. Try to find a co-founder that complement you, not the same as you, right? So that you can do A, then your co-founder can do B. At least you have more coverage, both of you. If both co-founder do the same thing, then who is going to do other thing that both of you doesn't know, both of you don't know. Right? So it is important for you to identify what is it that you require from the job role.
Thanks. So we're running out of time. I'm going to ask a very last question, and it's a kind of yes or no question. There has been a debate in the past years. We were saying product managers are going to be less and less useful because coders understand much better software and products. Now that no-code solution starts to appear, that the opposite talk, that product managers are the only defensible position because they know how to build products, and there's no need to code anymore. So I'm going to ask you, and you have to answer product manager or engineer. What's the job of the future? German.
Neither of the two is the architect. You need to understand the system, and that's it.
I
Yusup?
agree. Totally agree. Yep, totally agree.
Then we have
It's
an
the
answer.
brain. You need to know what you want to build.
It's not about being deep. It's about it's not either about being horizontal. It's about being a V, right? Having a certain depth in something, and then horizontal capabilities to know a bit more. All right, we're closing the session for today. Thank you very much for your attendance. We are going to send the slides on the invite for the next session. I just want to clap a little bit to thank our mentors today, German and Yusup. Thank you so much for your time and for the sharing. And Suzy, I'll let you close the session with some details.
Yeah, hi, can everybody see my screen? Yeah, so yes, so thanks German and also Yusup for the sharing. So for the next session will be on 17th of September. We have Paddy and also Rustam to share. So I mean for Paddy, he will be sharing AI in banking, and just as like what Vincent have mentioned, all the slides and also the recording will be like upload on YouTube. That will be shared by from the next invite and also on Luma, like to you guys. Yeah, so but before we leave, can I like kindly ask everyone to like on their camera so that we can actually like take a like sort of like a screenshot, like a photo shoot for everybody. Yeah, let me do it. Okay. All right. Okay. I will see. Okay, I got, give me some time. I got 3 pages to take screenshot. So okay, 1, 2, 3. And okay, second page. 1, 2, 3. And the third page. 1, 2, 3. All right. Thank you, everyone. Yeah, I will send you all the recording and the invite for our next event. Thanks. Thanks, Vincent, for
Have a
moderating.
great evening, everyone. Bye-bye.
Bye-bye.